volume of rectangular prisms and cubes. So remember, the volume is the amount of space taken up by a three-dimensional object. So for this little one here, the volume of that is how many 1 centimetre cubes fit into it. Now there's a shortcut for finding area of a shape. If this was a flat shape, the area of this face, you can see that there's 9 square centimetres, and we can do a shortcut by saying, well, there's 3 lots by 3 lots. So 3 times 3 is 9. Now that says that if I've got 9 centimetres squared here, every centimetre this shape goes back, that's 1 lot of 9 centimetres cubed. So there, 1 lot of 9 centimetres cubed. 2 lots of 9 centimetres cubed. 3 lots of 9 centimetres cubed. So you can see that if I do 3 times 3 times 3, the 3 dimensions that are all at right angles to each other there, I get 27 centimetres cubed. And if I broke that shape apart, there's 9 of them, there's 9 of them, and there's 9 of them. That's 27 centimetres cubed. So the volume for a rectangular prism or a cube is just the length times the width times the height. And you could write that as length, width, height if you wanted. And that will tell you how many units cubed fit into it. Because this is measured best in centimetres, I got centimetres cubed. A very small shape would be best measured in millimetres, and I'd get millimetres cubed, and this is a very big shape. We'll get metres cubed. So, for rectangular prisms or cubes, we write the formula: volume equals length times width times height. Underneath the equal sign, we put our next equal sign to say, now I'm going to say what the length and width and height are. Doesn't matter which is which, as long as you get the 3 dimensions, one this way, one this way, one going back. 6 times 3 times 4. Now the idea with the working out is that you write out what you're going to do, and then if you need your calculator, you get it and do that. So once you've written it down, 6 times 3 times 4, okay, that's 72. Volume, we said what we were going to say, and now we've got to say, hey, we've actually found it. Equal signs line up. 72. Now, this is metres, and then I'm taking out, well, how many metres squared if we go this way, and how many metres cubed if we go back. So that's given me my answer in metres cubed. This one here is 2 centimetres on all its sides, and it's a cube. So actually, we could model that with these little shapes. 2 by 2 by 2. Now 2 times 2 times 2 is 8. Do I have 8 of them? Yes, I do. Because when you think about it, that's 2 lots of 4. 2 times 2 was 4 centimetres squared there, and then going back 1 lot of centimetres cubed, 2 lots of centimetres cubed, that's 8. So that's how the formula works. But let's do this with proper working. Volume, I'll use the one without the times signs this time because it's exactly the same. There's imaginary times signs. Put the numbers in, 2 times 2 times 2. Must put the 2 signs in, the times signs in. Now, we're going to get the answer here. So volume equals 2 times 2 times 2 is 8. We were measuring length in centimetres. So centimetres, centimetres squared, centimetres cubed for volume. How many little cubes is it taking up? Now you can see we could have done a shortcut with a cube if we wanted. The cube volume is the side cubed. That's S, not 5. So we could use a different formula for the volume of a cube if we wanted, but the volume for a rectangular prism will work just as well.